Welcome everyone. So let's now welcome our speaker, Aimé from University of Twente, Netherlands.
Thank you. All right, thank you very much. And thank you for attending our talk. My name is Aimé. I'll be the speaker today. This is joint work with Mart, Ömer, and Vadim. All three are present here today. And you'll get to meet Ömer a little bit later because he'll do the demo. Let me start with a question. Who here has ever used COBOL? All right. And who here has ever used C? Okay, that is exactly the answer I was hoping to get. Let's start with a bit of background about why we're talking about COBOL in the first place. And COBOL is an instance of a legacy language. Now, what is legacy software? It is software that's been around for a long time, which is usually kind of outlived or outstayed its welcome. Legacy software can, therefore, be a problem. We have some numbers here on the screen. It costs a lot of money to maintain, to migrate, and in fact 75% of companies are concerned about finding the right IT personnel. It is often present in critical business processes. Think of banks, insurance companies, governmental organizations. And as I mentioned, maintenance and modernization are a big concern. Not many people actually know COBOL, but many people do know C. Let's go back a bit. I talked about COBOL, and COBOL is a really large language. It was made a long time ago. It's been worked on ever since. So implementing something in COBOL takes a lot of effort. For our experimentational purposes, we wanted something a bit more manageable. There is this great language called BabyCobol. It is actually made for this purpose, experimentation and education. And it's small enough to implement, but it still poses many of these legacy language challenges. For our interests, it is actually a subset of COBOL's data philosophy, as we call it. If you're interested, that's the webpage. It was actually presented here at SLE a few years ago. Now, at first glance, on the left here you see BabyCobol, on the right you see C. You don't need to know COBOL to see that this is quite different from what we're used to in C. We have very different constraints on data and very different things of what's valid data. Let's just run through it real fast. On the left here, we call it a record. It is a composite data structure, and it's most similar to a structure in C. This particular example contains two other records, which again are represented as structs in C. It starts to get interesting here. G is a field. It's as small as it goes in BabyCobol. It specifies S99. That's actually the definition of what it holds. S signifies its assigned value. 99 gives us 2 digits to work with. And we don't really have anything very similar to that in C, where we really talk about how many digits do we have. Something similar could be an integer, maybe a character, because it's quite small. So the maximum value you could represent here is 99. Well, for this top case here, you see a V appearing. This is a decimal separator. We're not talking floating points, we're talking fixed points. So we have 2 digits, then a point, and then 2 more digits. Could be similar to a double in C, but not quite. There's some semantic differences there. And lastly, XXX, and X is any character, basically a sort of string. Now, the data types are different, but wouldn't it be nice if you could somehow align these, reconcile these differences in data? On the left here, you see some BabyCobol code. On the right, you see some C code. I'll just run through the basic structure of a BabyCobol program. It's 3 main divisions. We have metadata, not very interesting for computers. We have some variable definition. So all variables that we use in our program, we actually define them in the data division. The rest is constants, or it gets added on the fly with some language features. And then that main block down here, that's the procedural code that you might look familiar. We define 3 variables: balance, amount, and success. The first one is a signed fixed point, second one is unsigned fixed point, and the last is just 1 digit. We start by assigning some values to these variables, and then wouldn't it be nice if we could call some other code somewhere else? In this case, we might want to call some C function named withdraw, and we might want to give it some arguments, balance, the amount that we want to withdraw, and then we want to know if it was successful or not. Then, of course, display the appropriate message, depending on whether or not we could actually withdraw that amount. So this is the goal. This is something that we'd want to achieve. And wouldn't that be nice if we actually could show you this? Ömer will do the demo.
Thank you, Aimé. Well, let me open my IDE. So, let's start with the left example. This is practically the same program that Aimé just showed you, and I'm just going to run the compiler and show you what happens. So, this withdraw is from this C function. For convenience, I've already compiled this to an object file, and with the command you see, I call the compiler, I give it the BabyCobol source, and I give it the object file that contains the C functionality. When I run this, the compiler starts up, it creates a file called exec, and when I run this, we get the expected new balance. And then on the right side of the screen, I have a slightly different program. This is for, let's say we have a C programmer that doesn't want anything to do with the BabyCobol data types. We allow for that, and well, that is done by this as primitive here, which allows us to call this version of the functionality that just takes 2 double pointers and lets the programmer just work as in they were working with a pure C program. When I run this, you see the same output, and well, it works just as well. I can also show you the intermediate representation that gets generated. For the first one, since we are just using the native BabyCobol data types, we can just send them over to C, and we can use them here as something called a BSTD number. Aimé will tell you a bit more what a BSTD actually is. And well, on the right side, we have a bit more code, which is indicated by the dashes on screen. That was first one line, but now we need to change the BabyCobol number to a C number, and this is happening for both balance and amount. And then we call the external function, and then when we re-enter into the BabyCobol site, we change it back to a BabyCobol data type and replace the original value with the changed one after we have done our computations in C. Yeah, that was the demo. So I would like to invite Aimé back on stage.
All right. Thank you, Ömer. So, that was a lot. Let's dive into the details of how this actually works. A global overview. We started with a mixed language code base. We had BabyCobol on the one side and C on the other side. What we do is maybe, can I point at the screen? Is that Maybe I can use the mouse. No. On the right, we see a BabyCobol source file and a C file. And in both cases, they use that thing in the middle. It says BSTD. I'll get into that in the next slide. It's a runtime library, which handles a lot of these semantical differences for us. Now, we have a separate compiler for BabyCobol and for C. We create object files, and then we link them together into one executable. That BSTD, that actually stands for BabyCobol Standard Library. Its responsibilities are aligning the data types differences between BabyCobol and C. And in fact, it implements part of the native BabyCobol behavior that we get. If we run just pure BabyCobol, it still uses our BSTD. This leads to a very interesting guarantee in that if you use this in C code, the shared library, you get the exact same behavior as you would with native BabyCobol code. What it provides is functionality for creation, modification, and also that marshalling, that conversion between C data types and BabyCobol, as well as some basic operations. Think of addition for numbers, subtraction, etc. Comparison. BabyCobol, interestingly, did not have a call statement. It was quite a small language for experimentation, so we had to extend it a little bit. This is a railway diagram of what that looks like. I won't go into the details of this, all of this. What is interesting is you see the by value or by reference, and as primitive as struct. This is what Ömer showed you in the demo. The difference in what do we need to do? Do we need to prepare this data for C code? Do we keep it in our internal representation, or do we, or rather, do we copy it or do we pass it by reference? In other words, our changes on the C side reflected back on our BabyCobol code. We're proud to announce that this statement was actually absorbed in a mild variation in the BabyCobol language specification. We'll talk a little bit about how we evaluated this. First off, the whole thing has been tested with boundary value analysis. We wrote many test cases to give us some confidence in saying our compiler does what it promises to do. But that is not the most interesting part, because it rather works quite well. What's more interesting, I think, is to have a look at the performance, because there is actually some price to be paid for having this convenience. On the right, we see a plot. On the far right, I'm not sure if you can read it in the back, it says by reference as struct. We don't need to do any special magic to make this work. Our internal representation gets sent over to the C side, and then on the C side, you get to determine what you do with it. But say that we're interfacing with some existing C library, for example. We might want to pass something as a primitive, as a C basic data type, and by value, right? You want to just receive an integer in your C API. We'll have to do some conversion there, and we generate the code for that conversion. We plug it in before we execute that call. But because we're passing by value, we don't need to actually check that what they do on the C side with it is valid in BabyCobol. Our last case, most problematic, is by reference as primitive. When I say problematic, it's the most performance intense, because we need to firstly make sure that we give the function a C basic data type. We also need to make sure that because we're passing by reference, whatever they do with that C basic data type on the C side needs to make sense in BabyCobol as well. So we need to reassert and convert to our internal representation. And some concluding remarks, and I can talk about this for hours, but I think we are doing okay on time. We asked ourselves a few questions. How can we, if we're talking about interoperability, how can we implement a foreign function interface? This is something that we believe goes towards interoperability. We have implemented our compiler using LLVM, and we make use of the ELF specification when it comes to deciding how we link these different compilation units together. How can the key differences in data philosophy between BabyCobol and C be addressed? Well, we have a rather large library for this. It's called the BSTD, and this takes care of all that marshalling, all those differences. We hope crossover can be a strategy for broader use, and in particular, we want to look at maybe the full COBOL language and see what sort of challenges we would find there. And if you want to check it out, it is on GitHub, it's open source. So yeah, that wraps it up.
Any questions from the audience?
Hi, I'm Eric Eide from the University of Utah. So I had two questions. So first, you showed basically invocations from BabyCobol to C.
Mm-hmm.
Is that the mode of use, right? BabyCobol is the program, and C provides functions, right?
Well, actually, we can do both.
Okay, so
both
it's a
ways.
bidirectional.
Yeah,
type
it's
of product.
bidirectional.
Okay.
And we wanted to show this because often people have a tendency to run away from COBOL rather than towards it. So this seemed to be a more interesting showcase. Yeah.
Okay. And then my second question is that, so I don't know the COBOL data model particularly well, right? But I would expect that a significant challenge is that when you translate it as C's native types, right? When you turn a fixed num into a double, the C code is free to return. It's possible that the C code will return a double that isn't representable in the fixed num format that BabyCobol expects. So
Yeah.
So how do you deal with that?
So let me go back a few slides. Actually, I do mention it here. What we do is we make sure that we unmarshal. We treat it as input to the system. We say we get some floating point value. We need to fit it into this specific field, this BabyCobol field. We know what that field looks like, and we have very clearly defined semantics from BabyCobol that state, look, if it's too large, if you have too many decimals, if the integer part is too large. In this particular case, you truncate, and you put it in that way. Yeah. And then for these different picture masks, these specifications, you have different ways of dealing with that unmarshalling.
Okay. And by truncate, you mean that you take digits off of the fractional part. And
Correct.
presumably
Yeah.
you impose limits, right? Minimum and maximum limits on the mantissa part. Right. I mean the part to the left of the decimal.
Yeah,
right?
exactly. Yeah.
Okay. Thank you.
We do. Thank you for the question.
I have one more question, just concerning legacy software in general. I'm just wondering how often is it the case that you actually have source code for this legacy software? Because a big thing, like I know, is a lot of the commercial products, right? So, but they have binary. So like they have COBOL, but you don't really have access to source code per se. The reason they have to deal with the interoperability is because they have this legacy binary, and that's kind of working, and they want to continue supporting that. So I guess so. How? Like this for this interoperability thing, like how often is it actually people have access to the source code? Like in that case, why don't they just port the source code into transform into some other languages?
Right. Yeah. So the challenge in that, there's a whole field about this. I think actually Vadim is very eager to answer this.
I'll try to answer from my side and as in my capacity as a co-author. But then if you want to add something, go ahead. It is true that for legacy software, basically three situations are possible. One is, which is quite common, that the source code is there and it's even being actively worked on. The fact that the piece of software has existed for 40 years is not stopping current development. So people can still continue to enhance it and fix bugs and what if there are any, or enhance it further on a daily basis. So that's what we are catering for here. The second scenario could be that there is no source code, so there is only binary code that has been deployed. Then you are up for a completely different set of techniques, which are basically reverse engineering. And then you can also have a third variant that nobody talks about, which is you have the compiled deployed bytecode and you have 5 variations of the source code and they don't know, they forgot which one was compiled and which one is actually deployed. And they don't know with which compiler and so forth, so we can't rerun the experiment because the last time it was compiled was in 1994. And then again you're up for yet another set of techniques where you try to figure out which source code actually belong to this bytecode, and once you've ascertained that, then you can go forward with the source code. Then you are back in scenario 1. But all 3 are occurring in practice, but the situation where you actually have source code and it's pretty available and maintained and whatnot, this is pretty common.
Right. But in the case that they actually have source code and like they are facing the trouble of finding the right talent, like people who know the language, right? Like if they're struggling so hard and they are actually paying people to read those really hard to understand code, why don't they, just rewrite those codes into some other different languages? Like what's the motivation?
Very good question. So suppose that you have a piece of software that has 250 million lines of code. That's the largest one that I have seen. It was from one Spanish bank, not the biggest Spanish bank, but the 4th biggest one. And it has been in active development for 40 years. And now you want to replace it with something else. Right? How do you do that? You also need another 40 years to rewrite it in whatever language you want to write it on. And then you need probably another 40 years to prove that the behavior of your replacement system is exactly the same as the behavior of the old system. Because the old system is integrated into all kinds of other systems. It operates with databases, database management systems, with job control language, it has integrated in a lot of places. So complete replacement of such a system is basically impossible because you need billions of resources, you need people, and you need a lot of time, and especially time is something you do not have. So what is possible is, for instance, re-platforming, where you move to a different compiler and then you deploy it on a different platform that, for instance, is cheaper for you. And what is also possible is once you get to some situation where people can continue development in some systematic fashion, do this when you integrate parts of a system in the language that you want to use. In this case, we assume they want C, but it could be that they want, I don't know, Java or C# or, I don't know, Haskell. I've never seen a COBOL Haskell system, but it is possible, technically. But for instance, there are several COBOL to .NET compilers, and then you can write F#, which is pretty much Haskell, without the crazy stuff.
Just the final remark. So let's say if you adopt this technique, but in the reverse direction, right? So let's say you're stuck with this 25 million COBOL code, and you want to incrementally port it to C. Okay? Is there sometimes it's not possible, right? Because maybe there are certain programming model where you're referring to global variables, and you simply factoring this code out. It just doesn't work. It can't incrementally do it.
Variables are not a problem in COBOL.
But is it even possible, like you can perform, say, you can incrementally port like part of the function, like the API, into a more modern language? Like, does it even make sense, like,
Sure.
It is actually, okay, yeah. Thank you. So let's thank our speaker again.
Thank you.